Hello. Today we're going to talk about how to extract data using web services and APIs. We've already talked about extracting data from CSV files, and if we know where our data is and we know it's already in a CSV file, then that's all we have to do. But sometimes we need to find the data and it's not in a CSV file and it might be given to us in a different format. So that's what today is all about, learning how to use web services and APIs. So, what are web services? Well, many companies will actually share their data with us over the internet so that we can use it in our own apps or we can use it as in some of our data analysis. Now, sometimes they do this for a fee. Sometimes it's as a public service. But there are lots of web services out there, and here's how easy it is to use a web service. First of all, basically it comes down to this, just typing a certain URL into the address bar of your browser. So whether it be Chrome or Microsoft Edge or whatever you're using, you just type in a certain URL. The trick is to know exactly what to type in. But if you type the correct thing in, then what will come out if you have accessed a web service correctly, you'll see a bunch of data that shows up in your browser. It might not be that easy to follow at the moment. It might be in something like this. It looks a little bit hard to you can kind of tell what's happening. It's not maybe in a real readable format, but the data is there. Now, for most web services, in order to get data to come back, you need to register for an account first and then be given an ID and a password. So a lot of times they call it an app ID and an app key. Or sometimes they call it a client ID, excuse me, a client ID and a client key. Anyway, they're called different things, but basically it's some login information. Even though many are free to use, you usually still have to go ahead and register for an account. For the examples that I'm going to look at today, I've already registered and I have this information. So you can go ahead if you want to and use my information, or if you'd like, you could go ahead and sign up yourself and get your own ID and key. So we talked about what a web service is. What are APIs? So, we talked about with a web service, all we have to do is type in a URL into the browser and we get data back. But also maybe instead of just seeing that within our browser, usually we want to do something with that data. So what we can do is still use that same URL, but have our own applications, like maybe it's a mobile application, a web application, or a Python script in our case, have that use the data. So we access the data and from that same URL, but we're doing it for another reason, not just to get it back to see on our browser. So in order to do that, we need to know exactly what the URL should look like and any other certain commands, any, just information that we need to know about how to type in this URL and how to work with this web service. So that's where an API comes in, Application Programming Interface. So each web service has its own application programming interface. And so you would have to take a look up the particular web service, and usually there's a place in there where it talks about the API, and you just have to go in there and look around and see, what would that URL look like, and what are some of the possibilities we have for typing in that URL. What if we want to search for certain things, or we want to sort it by a certain way, that kind of thing. That's where we have to find the particular web services API and find out how to do those kinds of things. Okay, so now what are RESTful APIs? Well, we said that an API is used in order to access a web service, and these APIs need to be able to communicate back and forth from the company's server to your computer, and there has to be a type of a protocol that's used in order to communicate. And so that protocol can come in a couple of different forms. One protocol that used to be used has been used for many years is the SOAP protocol. That stands for Simple Object Access Protocol. That one has been around a long time, and it's not probably used much at all, I would guess, anymore. The newer one is called Representational State Transfer, and we call that REST. So most of the web services that are used today are using that REST protocol. Now, as I said, REST is newer and more commonly used today, so that's pretty much what you're going to find when you use web services. And if you have an API that uses a REST protocol, sometimes people say that is a RESTful API. So if it's an API that accesses a web service and it uses REST protocol, then you say that's a RESTful API. Now, when we get the data back from a web service, as we saw a minute ago, we can just see it in our browser. If we just type the URL straight into our browser, it will be returned usually in one of two ways. It will usually be returned in the XML format, which is the extended markup language, and you see that on the left. Just a bunch of tags, kind of looks a lot like HTML. It says inside the tags, it says what is this information, and then it'll go ahead and tell you. So for temp max, you see it says 10.8, and that's under, if you look up a little further, you see the date. And so basically what that's telling us is at a particular place, and this doesn't show what I had typed in order to get this data back, but I think I typed in something like Olathe, Kansas. And so basically by looking at this, you can see it looks like the date for 10/3 2000. I was going to say that doesn't look right because October hasn't happened yet, but actually I had searched for March 10th, and in this for this data, the way it came back was the day of the month came first, and then the month. So that's why it says 10/3. We would usually see that as 3/10, March 10th. Anyway, so I had searched for March, well, I had searched, you don't see all the data here, but I had searched for a time frame. So I said something like March 10th through maybe the 12th or something like that. And so here for day, the first day, March 10th, you see all these different values. One was sunset, sunrise, and so on. And then that temp max, you see, it says, and that's in Celsius, but then we can go one more down, temp max F for Fahrenheit. And we see that was 51.5, so that was the maximum for that day. So anyway, that data would go on and on and on and have a lot of information in it. It's not really a real readable format, but that's one of the formats that our data can be returned in. Another format is called the JSON format, and we'll talk a little bit more about that here in a minute. That's where you see a bunch of curly braces and then braces within braces and that kind of thing. So we'll get more into that and talk more about that here in a little bit. JSON is what is used more often today. You still see some web services that return some data in XML, but JSON is more commonly used today, and we'll learn some more, as I said, about JSON in a few minutes. Now, as I said, some web services are free to use and others charge a fee. It's kind of fun to look around online to search and find different web services, what web services are available. We're going to be looking at some different examples here in some slides here in a minute, but just so in case you want to kind of take a look around, I've given you a couple of different places that you can look. There's a site called www.programmableweb that lists a lot of good web services. There's another one called Markup massshape.com. So you could do that, but also just search web services or free web services, and you'll get some others that come back too. So here's some examples. Bing has a web service. They call it Bing Maps REST Services. And if you want to, you can use that in your application. This isn't something we're going to be doing in our data analysis, but just an example of a web service out there. Here, what they tell you, you have to look around and read up a little bit about it, and then you find that after you sign up and get your key, you need this Bing Map key. So you'd have to sign up, get an account, and then get your key. Once you get that, then you can use this particular URL, and you can find the longitude and latitude of any address on the earth. So you can type in country, region, or admin district, locality, postal code, those kinds of things. And then you'll see that if you type that in along with your Bing Maps key, I guess we don't see an example here, but what you would get though would be it would return the longitude and latitude. It's one example, and you could go back the other way, I'm sure, where you could put in the longitude and latitude and then find the zip code or something like that. Here's one. Data.gov has a lot of data. A lot of the data is required to be posted and available for the public to access. So you can find a lot of data on data.gov. This says the home of the U.S. government's open data. It says here you'll find the data, tools, and resources to conduct research, develop web and mobile applications, and design data visualizations and more. If you click on the developers link up there at the top right, then you get something that looks like this, and here then it explains how you're going to be able to use APIs. It says data.gov is a rich resource for civic hackers, tech entrepreneurs, data scientists, and developers of all stripes. Here you'll find information about APIs, open source projects, and so on and so on. So when you click on that, then you see this APIs link here that you can click on, and you can find different APIs that would help you find a bunch of different types of data. Here's one that I found off of the Programmable Web website. It's a Spotify API. So this says it allows developers to use their application to get data from the Spotify music catalog. So this is probably one that would cost some money, but if you had a music app and you wanted to be able to have the user type in the name of a song and then get some information back, or maybe play that song or something like that, then you could maybe use this Spotify web API. Notice it says the endpoint results in JSON format, and that's what we would expect. Here's a weather API that shows some weather. Here under key features, it says JSON or XML formatted, so you can choose what you want, and you could go in there and look around too to find out all kinds of what you could get there. But that's an example where either if we found the right thing, we could maybe use that to pull back a bunch of data and do some data analysis. This is also maybe more geared towards people who want to put weather within their applications. So maybe they have a mobile app and they want to show the current temperature, or the temperature in a few days or something like that. Then they could, within their mobile application, go out and get this data and pull it back in and show it within their application. Here's another weather API that I found, and I was able to actually get an API key, and here they call it app ID and app key, and I went ahead and got that ID and key, so you see my ID and key in there. And if you want to use that, and play around with this one, you can. You see that once I typed that in, then you see this is kind of what I showed a minute ago, where you see the 10/3/2019, which is really March 10th. You see all the different information there for March 10th, and then you see then it goes on to other times too, other days too, where you don't see it all here, but you can, if you take a look, you see that there is a um, day of the March 12th down there too. Here, there's some web services out there that return sports data, and this is one I found, Sport Radar, and it shows that you need to, register your account, create a username, and then be able to get your free API key. And then once you do that, it kind of tells what to do to go about getting information. You can look that up and see all of the different types of sports data that they would be offering you to be able to find out. It does talk about, let's see, somewhere I saw it says register an application to get a free trial API key. So that leads me to believe that probably eventually you'd have to pay for this data. But I'm sure you can find some sports data out there that you could get for free. And here's one called the Open Movie Database API. This is by this guy named Brian Fritz. He just has all of this information about all of these movies that have been out and are coming out. He keeps it pretty much up to date, I think. So it says, I'll read a little bit here. It says it's an open database that sources movie information, from other movie sites such as IMDb, Rotten Tomatoes, and Wikipedia. So he doesn't obviously type this in himself. He goes and gets this, when a new movie comes out, he gets the information from those different sites. And probably uses web scraping, which we'll talk about here coming up. I think next, the next lesson will be on web scraping. So he probably does that to get the information there. But anyway, then it is compiled in his own way, and it says users can access the Open Movie Database API using REST or JavaScript. So REST is what we're going to use to allow users to search for a movie title, a valid IMDb ID, year of a movie, or plot. And this says the service is free to use. Notice down there protocols / formats. There's JSON and then REST. So we're going to use this Open Movie Database to just get some data back, just to see how this works. We're not going to use it within Python yet. Once we see how to use this, use a web service within our browser, then we'll go ahead a step further and use Python to extract the data and then possibly be able to do some kind of data analysis on it. But anyway, here we have the Open Movie Database API. I don't have you could search that and find that URL if you wanted to, but you can just watch me go through these steps here. This particular web service, and a lot of these web services are licensed under Creative Commons. So that means that you can, the content can be used for free in any way, as long as credit is given. So that's where you have to, in this case here, attribute, where did you get this information. So down at the bottom it says you must give appropriate credit, provide a link to the license, and indicate if changes were made. So, be careful when you're using, if you're just using it to bring back data and do some analysis, there's really not, a problem other than when you talk about your data, you would say where you got the data. But if you were using an API within your application, and your application, you're able to just type in a movie and you get information back from the movie, you wouldn't want to pass that on as your own. You would want to somewhere say, hey, I'm getting this information from this particular web service. So if you go to this website here, www.omdb api.com, you can look around and get some information about this API. Now, every web service has its own API, and they're all different. So you just have to look around on the associated web page to find out what does the URL look like that I need to type in order to get this data back, and what kind of parameters, what kinds of, what if I want to search, how would I do that? So in this case here, you see that first of all, it says send all data requests to, and there you go there. So see how that's a URL, and there's a question mark, and then API key equals, and so that's where we would have to put our own API key. And then there's an at symbol, an and symbol, and that's where we can add on some parameters. So see here, there's not too many showing, but there's a lot if you would scroll down on this website web page, and here there's like a type, and so maybe you are looking for, instead of a movie, a series. So up there after the and, you would put and type equals series. And then, as I said, you could scroll down this page and see all kinds of other parameters, and you would just list all of the different things that you want there within your URL so that you get exactly what you're trying to get. So you would look through those parameters, see what is available, and then see what you'd like to use, and then add that into your URL. So I had already found an API key, and so here is my key. So if you want to type that in for the API key, you can, to then see that you get some information back. It's 3244BF94. So before we do that, let's take a look and see what else they have on this page. This page, if you scroll down past the page we looked at, if you scroll down past the parameters, then you see this little box where it says examples, and this is great because it gives you an idea of what the URL is going to look like, and also what the data will look like that comes back. So here it lets you type in a title and or a year, and plot summary. Do we want the long plot summary or the short one? And then how do we want it response? Do we want XML or JSON? So we typed that in. I typed in Gone with the Wind for the title, and then I clicked on search there, that search button. And if we did that, then here's what it tells me. That web page goes ahead and says, well, this is the URL that you would need to use if you're searching for Gone with the Wind. And it says it has Gone with the Wind as T equals. So after the omdbapi.com, then there's the question mark and T, and evidently T is what stands for title. A T equals Gone with the Wind. Notice instead of a space, we have pluses between our letters. So in URLs, sometimes there's special things we have to do. So that's one of them, but you wouldn't have to really know that yourself. You would just go, in this case here, you type that into the page and see what the request would be, and then you realize, oh, okay, if I have a title that has spaces in it, I need to be sure and put a plus sign wherever the space is within the title. Okay, now this doesn't show it because it's assuming you're also going to put in your API key. So you would also, if you just typed what I had above there, you probably wouldn't get anything. But if you add to that and every time you put in a new parameter with a value, you have to put the and symbol in. So we would do T equals Gone with the Wind and API key equals, and then that particular API key, and then we'll get some data, and it should be in JSON format. And here's what we get. If I type that into my browser, this is what we get. So this is a bunch of JSON, and it's kind of hard to follow at the moment, although we can kind of look and see. Looks like the title is Gone with the Wind. It gives us the year, what was it rated, and when was it released. So it gives us a lot of good information, but it's just all kind of smashed in there together. We could put some line breaks in and some white space to see what's actually there. And so we can see that's a lot easier to see. But instead of doing that ourselves, we could use this online JSON viewer. Here's the URL for it, you see. And what happens is you can grab all of that big, clump of data that's kind of all smashed together, copy it out of your browser, and then go to that URL and just paste that in there, and then it'll reformat it for you so you can see it's in a really much better format, and you can scroll through that. And also when there's objects within objects, then there's little trees and plus signs that you can click on and expand things. So that's really nice to be able to do if all you're doing is taking a look. Now, usually, as I've said, usually for us, we don't really care about looking at it in the browser. We're going to want Python to pull it in and use it. So that's something that we won't really have to worry about. But if you ever do, it's usually a good idea, though, to go ahead and pull it back and get some data to come out in your browser, just so you know that the URL is correct first, and then maybe you want to kind of just look and see what comes back from the browser so you know what your Python should be looking for. But then, so it's a good idea to go ahead and use the browser the first time just to see what comes back. But then you know that you can look at this, see what's there, and then you'll know what to type in for Python, and we'll be talking about that here in just a minute. So let's talk for a minute about JSON. So JSON stands for JavaScript Object Notation. It's a popular data format. It's lightweight because it doesn't require, it's not in some format that requires some software to open it. It's just in text. We could open it in Notepad if we wanted to. And it consists of name value pairs. And this is saying it's commonly used, JSON is commonly used to pass data over the internet. So when you see something, let's look down here in the example. You see these curly braces. So braces denote here, let me show this. Braces denote where an object begins. So an object begins with a beginning brace and an end brace. So for instance, this here, all of this down here, that would represent one object because it's within a beginning brace and an end brace. Inside the object, there are going to be name value pairs. So first of all, we see first name, John. So that means, okay, for the first name, for this particular object, this particular data point, the first name is John. Last name is Brown. So that's what objects are going to consist of, are just these pairs. What's the name of what, basically think about it as what would be, we'd consider the attribute or the column name or the feature, and then what's its value, and then what's another one and what's its value. Okay, each name is followed by a colon, and then the value is going to come later. And then if we have more than one name value pair, which usually we do, we would have each of these name value pairs separated by a comma. So anyway, this particular object, we would say, holds values for first name and last name. Now, it's possible to have objects within objects. In this case here, we start with an object, start with a beginning brace, and its ending brace is down here. So it looks like we have one, which you might consider like one record of data. We've got just, something called a wall mirror, and it has a price and an ID and so on. But the way this is set up is that it has also an object within this object, because dimensions in this case, evidently, the the um, the value for dimensions is going to be its own um, version of an object. Evidently, in this case here, they have the data set up so that each record is going to have something under dimensions, but that's going to then be an object inside that holds length value and a width value. Also, they've done this for warehouse location. They've said, okay, for warehouse location, we want that location to hold two different things, the city and the state. And so they would put those name value pairs inside the braces because they're expecting the warehouse location to be an object itself, which would consist of the city and state. So we can have objects within objects. And also we can have collections of objects. So if I put a comma after that first one that we just looked at, and then have another one, then that's just going to list another object. So the first one was a wall mirror, and it had a price and a bunch of information. The second one is a golf club. It has a price and a bunch of information, and we can just keep listing them with a comma after each one until we're completely done. Notice here that when we have the collection of objects, we do have an extra beginning brace and an extra end brace saying, okay, we're starting out, here's an object. Okay, so let's see, we start out with the first brace, and then we say, here's an object here, and then there's a comma right there, and then here's another here. And when we're done, then we have this end brace there. Now, you don't really have to worry about this. We're going to have Python look that up and figure all of that out for you. But I'm just kind of trying to give you an idea of what does JSON look like, and what does all of that mean. Okay, so let's look at our results that we got when we typed in that URL into the OpenMovie Database API. Here's what we got, a bunch of information about Gone with the Wind. And you see it's in JSON format. There's a beginning brace, and really we only got one little record back. And so it's just within this case here, we just have one little object, and it just has a bunch of column names. So one open brace, one closed brace mean we just have one little record. And look at these names here as names of what you might consider columns, and then you see their values. So the title would have Gone with the Wind, year is 1939, and so on. And as I said before, it is usually a good idea to use the browser to try out the URL and see what you get back, so that you know that URL is going to work. But as I said, we're going to not try to analyze any of that data just by looking at all of that stuff in the browser. We're going to use a Python script in order to be able to load the data into a data frame, a Pandas data frame, and then we can do some data analysis on it, just like we've done in the past. Okay, so we're going to use Pandas with Python and extract some data in this new example from the Yelp API. So I don't know if you've worked with Yelp before, but Yelp is a website that keeps track of businesses and ratings. People can rate businesses on Yelp, and lots of different information about businesses that you can find on the Yelp website. But Yelp also, even though most users wouldn't use an API, they would just pull up Yelp and look up a business just to get some information in English form. We as data analysts can use the API to just pull back some data, and then we can get that data loaded into a CSV file and then um, we can pull the data in from the API and do any kind of data analysis we want to. But if we want to save it, then we could also then load it into a CSV file. Okay, so we need to make an API call to Yelp's repositories. So we would need to look up Yelp API and see what does this URL look like and what are some parameters that we can type in order to get exactly what we're looking for. So here you see I've given you a place to go, www.yelp.com developers documentation v3. So that will help you. You can go there if you want to look around the API. What I did is I signed up first. So I already signed up and I got a special password. Sometimes it's called like an app secret or an app ID. Sometimes it's called an API key. There's all kinds of words they can use for it. Sometimes it's even called a client secret. So anyway, I don't know. We'll find out here in a minute what they actually call it. But I did go ahead, sign up, and then I went into Manage App and was able to then get my special password and ID that I needed. So once I signed up and said that I wanted to use the API, then they gave me this API key. They call it a client ID for the ID value, and then for the password they call this API key. This is something obviously you wouldn't want to type in, so I have this in text form right here. So you can go to the notes and the PDF file with the notes, and hopefully then just grab that information, copy that information, and put that into the URL if you're going to follow along with me and do what I'm going to be doing. Okay, so now that we have our client ID and the API key, we can look around this API and try to figure out what URL would look like, what the URL would look like, and what type of parameters we would need to type in. I have the URL here for you if you want to click on that now and look around. So when I clicked on that search, because let's say we want to search businesses, you see that it gave some information. It gave us, just like we saw before, it tells us what we should expect, that we would expect the URL to look like that we would type in. But it also gives us some parameters. So if I were interested in, they have this thing called term, which is kind of a weird term. It says you can search term like food or restaurants, and if term isn't included, we then would it would search everything. It also says that the term keyword word also accepts business names such as Starbucks. So if we wanted to put a name in there, we could. What we're going to do, and I've kind of covered up most of this, one thing to look at is this limit here. It says that by default it's only going to return 20 businesses, but if we want to bump that up to 50, which is the maximum, we can do that by saying limit equals 50. So that's what I'm going to do here. I'm going to put limit equals 50 in there. So I've started with this request up here at the top, this URL here, and then I've put some parameters in. So I've got limit equals 50 and term equals food. Location equals Overland Park, and I say sort by rating. Now you don't see that here, but if you looked on this page, you'd see that, oh yes, there is a parameter called called location, and there is a parameter called sort by, and you could even search other things too by finding some other different parameters that you could use. But these are just the ones that I used. And so if we first of all just type that into our browser, we'll see what we get. Oh, and we didn't have to do that because also on this same page it will tell us what we would see if we type something in. So it gives us an idea what that data is going to look like. Notice that we see that we have, here's the beginning brace here, and then there's the end brace way down, we can't see. But it looks like before it starts listing businesses, it says total equals, which means that there's that many businesses within our whatever we searched for. And this came from the website, so it's not necessarily that search that I just showed in the last screen. So anyway, it's saying that there's this many businesses, and then it's going to list the businesses. So then it has this name value pair. The name is called businesses, and then what's in there, it's going to be a whole list of a bunch of businesses. So here's the first business. And let's see, is that right? No. Sorry, it's the whole, I guess this is the whole business here. So the whole thing, but it is a list so that you'll see more and more businesses after this one. Again, you don't really have to worry about this. We're going to learn how Python can take this and pull this in, but I just kind of wanted you to know this, to notice this, that it starts with a total value first and then doesn't start listing the businesses right away. That comes later within another name value pair. The name called businesses, and then the value would be this list of businesses. Okay, so let's get ready to use Python and Pandas to do this. Now, I will show you a little demo. I'll have a demo video posted that you can look and see me perform all of this. So I think what I'll do here is just explain the different commands, and if you want to, as you're listening, you could type these in and try them out as we're talking. Or if you want, you could just listen to see what all of these different commands do. And then later you can go in and type them in and try to get it to work yourself, or watch my demo. So first of all, here we're going to open Spyder, and we need to be, since we're going to be making requests to an API, we need to import a library called requests. So you would type import requests, and then as you've done before, we're going to use pandas, so you would also type import pandas as PD. So now we can use both of those libraries, requests and pandas. Now we have to set up our credentials. So sometimes this API key is sent along with the URL, but that's not as secure. And what you can do instead is send the API key in something besides the URL, send it in something called a header, and you'll see how that all fits together. But for now, just take a look here at these two statements. First of all, we're creating a variable called API key. And so we say API key equals, and then I just have in there, you can use mine or get one of your own. So you can put my API key in there if you want to. And notice it's within single quotes. And then the header, and I just called it, we can call this anything we want, but it's a header, and this is how we're going to be sending in the API key. So we already have, if you see in that second command at the very end, it says API key. So whatever we have saved in our variable called API key, it's going to go in right there. So now, the second statement, we're just creating a variable called the header and saying what's in there, and then it has all of this in there. Don't worry too much about what are those percentage signs, that kind of thing. It's mostly, I think I just got this from information off of the website. So maybe each header would look a little different depending upon which API you're using. And as I said, sometimes APIs just have you send the API along within the URL. Hopefully this isn't too confusing. So we'll hope it's not. Okay, so the header is going to include the API key, and then it's going to eventually, we're going to pass this header along with the URL to then get the data. Okay, so now we will make the request, but first of all, we're going to say what is that URL that we're going to use. So again, we create another variable called the URL. And so this here, the URL we're saying is equal to, and then we've decided which parameters we want to put in there, and we've put those in, and also now we have, we also have the main URL that we found off of that page. Now here's where we use this requests library that we've imported, and it has a command called get. And then we send in the URL. So the URL equals, and we just said what the URL equals. So we just had a variable called the URL. So we'll say that that's what the URL is here. And then headers, we already had in the previous slide, we had created a variable called the header that had our API key in there. So we'll pass that on into for the header. So we're making the request and sending along the URL and also this header. Okay, now we're creating another variable. Let me get this set up here. Here's a new variable called Yelp data. What's it going to hold? Well, based on the name, we assume it's going to have some data in it. So what do is we call this command, and that's not something you would have had to have known. This is just, these are the commands that we use with Python and Pandas to use an API. So we use the requests.get, and then we say response.json, so that whatever the response that we get is going to be put into some JSON, and then we say what do we want to call it, and in this case we're calling it Yelp data. So we're going to put the JSON that's returned into an object called Yelp data. And now that we have that data, we can put that data into a Pandas data frame. So here you see df equals, and that looks familiar, I'm sure. And then here's, maybe this is new because we haven't had to do this yet. We're wanting to pass in the Yelp data that we just got. Remember that Yelp data, that data we got, I showed you that it started with the total number of businesses. So we don't want to just send in all of that stuff. We want to focus in on just the list of businesses. So that's why we do this here, Yelp data businesses. And then we can specify what columns, because there was a lot of information in there and we maybe don't want everything. So maybe we just want the name, the rating, and how many reviews were turned in for that particular business. So what that does then is put all of that information into a data frame, so that we would have all that and then be able to do anything that we could do before with the data frame. Now we could do for this data. So if we take a look at our data frame, once we have created it, the data frame called DF, we'd see this is what we get. And you see that there's a name and a rating and a review count. That's what we were asking it to save into our data frame. And we also have a list over on the left of which line number it is. So it starts with 0 and goes on up. Now, if you remember that URL, we had sort by rating. And so you would think then that these ratings then should be in order. If you look under the ratings here, you see that there's starts with a 5, so it appears that maybe that sort by is going to, in terms of Yelp, if we're sorting by rating, we're usually probably wanting the highest rating first and going on down. So if we said sort by rating, it's going to assume you want the highest rating ones first. So it starts out with a 5.0, but then we've got some 4.5 and then another 5.0 back here. So it doesn't look like it's sorted very well by rating like we asked it to. But if you take a look at the documentation, we'll see what's going on. So we'll go back to that web page where it talks about the parameters and look under sort by. And it says that note that specifying the sort by is a suggestion, not strictly enforced. For example, the rating sort is not strictly sorted by the rating value here, but by an adjusted rating value that takes into account the number of ratings similar to a Bayesian average. This is to prevent skewing to businesses with a single review. So, you know, it's if only one person has reviewed it and it gets a 5.0, that's not going to be up there with the highest 5.0s because it's only one person thinking it's high and only one person even rating it at all, you know, with an average of 5. That's not going to be meaningful. So that's why it might not look like it's sorted by rating strictly, but they took into account, you know, using an algorithm that's behind the scenes that you don't have to worry about, and said that they think this is the order that we would care more about. Okay, so anyway, that's why it might not appear to be in order like we would expect. Okay, so now that we got those the top 50 restaurants, because we sorted, and remember there's a limit, the highest number of data records that would be returned was 50. We set that limit equals 50. So now that we got those 50 restaurants with the highest reviews, we can then use pandas to sort by another field or do anything else we want to do with pandas. So here if we say df equals, and now this is just using pandas, df.sort values by review count, we could do that. Here this is pandas, so here if we want it to be sorted by review count the highest, pandas doesn't know what the ratings, you know, Yelp would say, oh yeah, we know if you want to sort by review count, you want the highest ones first, because in the context of Yelp, those would be the best. But Pandas just sees that as a number. So it's going to probably try to sort the values from the bottom, from the lowest to the top. So that's why in this case here, we would want, if we want the businesses with the highest number of reviews to show up first, we would have to sort it in descending order. And the way you would do that with pandas is say ascending equals false, so that it's in descending order. So now you see that these have been sorted. Again, we know that they're the top 50 restaurants with the highest reviews, and now we see that we have them sorted now by review count. So now we see that the ones with the highest review counts are first, and then it goes on down from there. Now that we have that, and you know, we could do a lot more with that, but this is all we're doing for this example, just to show you how you get this data. Now we can save that into a CSV file if we want to. So we could say df.toCSV and then name the CSV file. And remember that if you're using Spyder, just check to make sure that you have that working directory set where you want to save your file, and then it will save the file there, and then you'll have that. So we've actually gone through an ETL process. We've extracted the data, but we extracted it using a web service, and we did transformation basically just by pulling out, well, we did a sort just to find the top restaurants. Then we pulled out certain columns that we wanted to see, and then we even sorted again by review count, descending order, and now have that data. And so that was the transformation, and then we have loaded it into a new file called Overland Park Restaurants CSV. So here's all of the code together on one slide. So first of all, you see that we imported the libraries. We set up the header, put the API key into the header, set up the URL, and then put the header and URL together inside this command that's going to make the request. We called it response. Then we turned response into JSON format and put that into Yelp data. And then we found just the businesses within the Yelp data and said what columns we wanted and put that into a data frame. And then once we got the data frame, we did some more sorting. And then we saved to a new CSV file. So again, let's kind of go over how did we come up with the URL to use in order to find these businesses. Well, we had to go to the Yelp website that talked about the API. We found the part of the API that we were interested in, which was the searching for businesses. And so then once we got to that point, we were able to find this, what does the URL look like? And here it is, it says that's what the URL is supposed to look like, but then it has the parameters that we might want to consider. And this doesn't show all the parameters, but it just shows some, and it shows, yeah, there's something called a term and location and so on. So that's what we decided to use, the term food, location equals Overland Park, but there were lots of other things down further that we could have used. And in our example that we just did, we actually did do some more because we had a sort by part in there too. But that's what you would do, is just kind of take a look around in the API and decide what you want to put in your request. And then how would we know exactly what goes into that data frame method? Well, so again, like I said, if the website says that this is what you should expect with getting the data for if you request some data, this is what you would expect. We would see that again, that we wouldn't want to just get everything, because we don't care about this. That's going to mess up our data frame. We just want a bunch of records that has business information in. So here's a business here. Here's our first business. So that's why we specifically said we just want to look into Yelp data businesses, and then it'll bypass this total. And then we said what columns we wanted. Okay, so now I have a lab for you to work on for your assignment. In this lab, called the API lab, there's actually two options. You can do just one or the other, or both if you want to, but I'll only be looking for one. The first option is kind of using the same, it's using the Yelp API and just making a few changes. So it's not getting too detailed into anything that we haven't talked about, so you don't have to look around and learn a new API or anything. But the second option is if you are ready for a challenge, I give you a completely different situation and you would need to go in and look around the API, come up with your own URL, come up with, how you want to work with your parameters, and then find some data that way. So it's up to you if you want to, which option you want to do. But if you have time and want to do both of them, it's perfectly fine to do that too.